In the last video, we looked at the component elements of a biome: climate, vegetation, and soils. This time we'll look at the individual biomes and biome shifts. Just to refresh, here's our map of the basic climate zones. Remember that A was tropical and warm all year, so it should come as no surprise that it's located around the equator. B is also warm all year, but dry, so we find it farther from the rainy ITCZ and in the rain shadows of large mountain ranges. C is temperate, with distinct winter and summer. D is the continental climate, and E is the polar climate. H, of course, is that unpredictable highland climate that can often bring cold temperatures, but also very rainy or dry areas. Before we jump into biomes, let's get a few more terms under our belts. Ecosystems refer to the living things and physical environment in a particular area. This includes producers, consumers, decomposers, and energy and fuel. Ecosystems come in many sizes, from small to large. Food is distributed through the chain, and matter is recycled. Plants use energy to produce carbohydrates, which are consumed by herbivores, which are consumed by carnivores. Plants and animals die and are broken down by decomposers into organic and inorganic material that then feeds the plants, and the cycle continues. Just like the hydrologic cycle, damage to any one part of the cycle will be passed along and can irrevocably damage the whole system. Within an ecosystem, the balance often shifts between surviving and thriving. As mentioned, if one thing is altered, it impacts the whole cycle. Some species adapt to their habitat to compete more successfully. Others are able to dominate by competing more successfully than others, by a considerable margin. If one species dominates to the point that it eradicates all others, this removes diversity and can upset the balance of the whole ecosystem. Biodiversity refers to the variety of species present in an environment. Diversity improves community survival. Areas which are populated by a single species face extinction if something causes that species to fail. This is why the reduction of commercial agriculture to only a few varieties of a crop is such a risk. Human activity quite often removes diversity by removing a forest to put in crops or houses surrounded by green lawns. Government protection is often needed to protect areas of high diversity as they are facing increased threats. Environmental mitigation, conservation, and managed biodiversity can help restore or preserve diversity. Nature is remarkably resilient, but we have to give it a chance. Plants emerge in a pattern, each community surviving, thriving, and then altering the environment sufficiently to allow the next community to emerge. Each successive community grows more slowly than the last. Overall growing speed is affected by catastrophic events and remnants of climax species which may exist in seed form at the beginning of the cycle, such as after a wildfire. Agricultural land, which is left to return to a natural state, may start at the grass stage rather than with pioneer communities. Pioneer communities like lichens and moss come first, then grasses and herbaceous weeds. Shrubs and softwood trees grow more slowly, but eventually shade the pioneer communities to the point of domination. Eventually, climax communities dominate, which are the end species to establish in a region. Hardwood trees, which tolerate some shade and grow up underneath the pines, eventually grow to shade the pines, which die out. Their seedlings can grow up in the shade and then eventually reach the sunlight. The community stabilizes, and climate and soil are enhanced by these communities. Biomes are a group of ecosystems with particular characteristics. They're classified by their climax community. We'll look at the major biomes: tropical, temperate, and boreal forests, grasslands, deserts, and tundra. If you're thinking this looks similar to the climate map, you're right. Climate is a major component of biomes, so we would expect to see a strong correlation. Let's look at some of these in more detail. The first group of biomes is the forest biomes: temperate and tropical rainforests, broadleaf deciduous forests, and boreal forests. Let's look at each of these in more detail. When trade winds meet in the tropics at the intertropical convergence zone, warm, moist air is forced upward and creates a low-pressure system. As the air cools, water vapor condenses and precipitation occurs. Consistently high precipitation and temperatures characterize these biomes. Tropical rainforests are home to hundreds of tree species and incredible biodiversity. The consistent sunlight and rainfall is conducive to very tall trees, as they don't have a dormant season, but leaching from the humidity means that there are few nutrients in the soil. All of the biomass exists within the canopy, so when the trees are removed, the nutrients are lost. One of the most distinct features of the tropical rainforest is the vertical habitat. There are 3 main canopy levels: the tallest trees, which can reach 200 feet, then the mid-level canopy, which needs less sunlight to survive, and finally the lower canopy, which is heavily shaded by the trees above. While there is ample sunlight year-round, very little of it reaches the forest floor. Between 30 and 60 degrees, the prevailing winds are from the west. Cold, dry air moves from polar high-pressure areas and meets warmer air moving from the subtropical highs. This system results in weather systems moving from west to east, bringing moisture to areas east of water bodies. This is true in the northern and southern hemispheres. Temperate rainforests are characterized by ample rainfall, but cooler temperatures than tropical rainforests. The marine west coast climate is one place these forests are found. The upper canopy in these forests is dominated by evergreen conifers, suited to cool periods, but they grow quickly when warm. There are relatively few species compared to tropical forests. The mid-latitudes are also home to broadleaf deciduous and mixed forests. Several tree species, but fewer than rainforests. Seasonal cold limits growth. Trees go into a state of dormancy even if they do not drop leaves. Soils are rich in nutrients, so these areas often experience clearing for agriculture, but replanting successfully restores forest cover. In the winter, the deciduous species drop their leaves, as can be seen in the center bottom picture of my backyard when I lived in Ohio. As we continue to move toward the poles, we see even fewer tree species. Above 55 degrees north or south, the polar front influences climate. There isn't much land in the southern hemisphere, so this mostly occurs in the northern hemisphere. Cold, dense air moves irregularly from polar regions. The extended cold season is challenging for most trees, but conifers are better suited to both cold and dry regions, as needle leaves retain moisture better. Evergreens grow and transpire year-round, and needles trap moisture, which evaporates instead of processing through the soil. The trees do still draw moisture and nutrients from the ground, but this creates very acidic soils, as there's little organic matter to replenish the nutrients. Grassland biomes are also found all over the globe, and like forests, their nature changes depending on climate. Tropical zones with less moisture don't form rainforest biomes, but instead are a mix of grass and trees. After warm, moist tropical air rises and precipitation occurs, the cooler, drier air sinks and forms subtropical high-pressure areas around 30 degrees north or south. The ITCZ moves within the tropics following the thermal equator, making for wet and dry seasons, wet in the summer, dry during the winter. These can be very lush during the rainy season, but do not develop the dense tree cover or vertical habitat of the rainforest. Trees are widely spaced with extensive grass and shrub growth. During the dry season, the grasses go dormant, and trees draw on deep root systems. Fire is more damaging to the trees, keeping them from domination. The rainy season causes soil weathering, but leaching is not as common due to dry periods. Mediterranean chaparral requires periodic cleansing by fire to prevent larger catastrophic fires. Where there are human settlements, fire suppression has historically been the preferred strategy. As we've experienced in California, fire management needs to include periodic burns to reduce fuel for huge fires, but people seldom want that happening in residential areas. We often think of the Everglades in South Florida as perpetually wet and swampy, but this area also has a dry season and in late winter can experience large fires. This biome occurs on western coasts in the mid-latitudes. They experience dry summers similar to the Mediterranean climate because of shifting high-pressure cells and wetter winters as the jet stream moves southward. Mid-latitude grasslands are characterized by semi-arid climate, with hot summers and cold winters. Grasses grow rapidly during warm weather, fall dormant when cold or dry. Forbs, which we often think of when we think of wildflowers, are common. This region is well suited to agriculture, particularly grass-like grains such as wheat and millet. The amount of precipitation directly corresponds to the length of the grass. When we describe an area as prairie, we're typically referring to tallgrass prairie. Shortgrass prairie, particularly as you move farther from the equator, is often referred to as steppe. Deserts are defined by their moisture level and can be warm or cold. Moisture is very scarce and vegetation must be adapted to drought conditions. Many have a waxing coating, which preserves moisture. Needles repel herbivores so species can survive. Many enter periods of dormancy, reviving and sometimes even flowering following a precipitation event. Nutrients, especially salts, are located near the surface due to significant evaporation activity. Reduced plant species means reduced animal species. Cold deserts, such as the Gobi, are similarly limited in species. Tundra biomes have very short growing seasons. Recall that areas in higher latitudes receive far less insolation throughout the year. They are also characterized by freezing temperatures and are found in the continental climate zone. Plants are shorter to stay below the freezing winds, and the snow cover serves to insulate them. Permafrost, permanently frozen ground, impedes drainage. Organic matter sits on top of the soil rather than being mixed in, so soil fertility is limited to the first few inches of soil. Tundra exists at the northern edge of North America and Eurasia, but can also exist at high altitudes. If temperatures never rise above freezing, the area is covered in permanent ice, which we find mainly in Antarctica and Greenland. Highland zones are subject to rapid changes in temperature and precipitation, making them harder to classify. At high elevations, they resemble tundra biomes, but at lower elevations may more closely match a mid-latitude or tropical biome. While we've been talking about biomes in the sense of distance from the equator, distance from sea level can also play a role. As you increase elevation, temperature and moisture decrease, leading to similar changes in climate and biomes that we would expect from a change of latitude. But why is this? Alexander von Humboldt, for whom our university is named, was a German explorer and naturalist who traveled the world and documented what he found. He is often credited with being the father of physical and biogeography, because of his extensive writings on both subjects. One of the first things he published after his return was this map, which explained the phenomenon of altitudinal zonation. For every 1,000 feet you climb up a mountain, you lose 3 degrees of temperature. This temperature change may seem minor, but if you are 10,000 feet above sea level, it will be 30 degrees colder than it is at sea level, which is significant. 30 years later, around the time von Humboldt was publishing his findings, another German discovered Mount Kilimanjaro in Tanzania. A snow-covered mountain in Africa? Near the equator? His colleagues laughed at the idea. Despite von Humboldt's writings, it was another 15 years before a second German expedition visited Kilimanjaro and confirmed its snowy existence just 3 degrees south of the equator. Here's an example from the Canary Islands. As you climb the sides of Mount Teide, which rises about 12,000 feet from the ocean, you can see this in action. Banana plantations give way to mixed forests, typical of mid-latitudes, which give way to boreal forests, and ultimately to high grasslands and tundra. Closer to home, we can see this in the Sierra, with decreasing vegetation as you climb. The biosphere is that space between the atmosphere and the lithosphere where we live. The biosphere processes CO2, which impacts the atmosphere. Soil erosion and human activity can clog the atmosphere and modify climate. Plants are critical to the hydrologic cycle and the formation of soils and processing of carbon. Modification of the biosphere can impact carbon levels, water availability, and overall climate. Everything is connected to everything else, which is why climate change is something that affects us all.